you very much. This is really a pleasure. And anytime that I get to speak with children and students is no offense to the adults, but I do enjoy working with the kids a bit more. So what I'm going to do is, I didn't know that there would be so many kids during this session. So I'm going to use some pretty big words, but that's going to be pretty cool that you can actually talk about, Gino and Bernice, because then you can talk about what biomimicry is and what nature-based climate solutions are. And if you have any questions, we're going to have an actual Q&A session, just informal, toss out any questions, and then some breakout activity as well. So just, if there's anything confusing, just kind of think about it in your brains and park it in your mind, and then you can ask me later. Does that sound good? And no offense to the adults, but kids get precedence on the questions. That's how I operate. All right, so I'm going to share my screen briefly. Okay, great. Fantastic. So hang on, let me minimize that. Okay, so I'm going to start by just discussing about the Center for Nature-Based Climate Solutions, who we are, what we do, why we do it, and where we actually focus our research. So the Center for Nature-Based Climate Solutions, or CNCS, is a newly set up center under the National University of Singapore, led by Professor Koh Lian Pin. He's this amazing global conservation and research scientist that he works all over the world, and now we have brought him back to Singapore to start up this center. So I'm going to start by discussing a bit about what nature-based solutions are, why they're important, and in particular, to give you all an idea of the groundbreaking work that we're doing in Southeast Asia and tie it into its educational components. So then we'll follow by a Q&A session and a breakout. So if you have any questions, again, jot them down, park them in your brain. And again, kids get precedence on the questions. So Gino and Bernice, think of those awesome questions you got. And we're going to see about how it actually ties into your subjects, your region, your schools, your home. And that's going to be our breakout discussion. So we'll have a nice dynamic conversation about that as well, and how you think about integrating nature-based climate solutions, or NCS, into your lessons, schools, or towns. So what we are is we're focused here at CNCS is producing world-class research on climate change impacts and solutions. We are focused on producing knowledge and using our insight and expertise to become the go-to NCS center in the region. In other words, a big part of our mission is turning our research into reality and advancing NCS in the Asia-Pacific region. This just isn't about doing amazing research. It's about working with our communities, working with our policymakers, and my specialty and what I really love, obviously, is working with schools and kids and outreach. So in our center, our top priority is to produce evidence-based, interdisciplinary, and policy-relevant science to inform climate strategies, policies, and actions in Singapore and the region, and also globally. Our second and equally important goal is to build capacity and empower society and its leaders to respond appropriately and decisively to climate change challenges and new opportunities. But with the center, we're bringing together researchers from across disciplines and departments, faculties, different types of teachers, and even universities, to pool our expertise and resources to work towards our common goal. The research and the expertise of our center's research are really, really diverse. So diverse means just we're all over the place in terms of what we do and what we specialize in. So currently, we include marine biologists. So that means we study the oceans, mangrove ecology, forest ecology, as well as conservation science for a whole range of different ecosystems. We use remote sensing. So remote sensing is basically using satellites and images to analyze them in our computers and to understand a little bit more about the Earth. And environmental policy, governance, and law. So the center is invested in 5 strategic areas. In terms of its impact, as a small country, Singapore is heavily dependent on trade and therefore highly vulnerable to climate impacts in the region. The most obvious is an impact for our food security, and this has not been made more obvious than during COVID. Are there more insidious impacts that we need to prepare for? I think we've now understood that with the global transportation and shipping, as well as our education system halted with home-based learning, that we have a lot to learn about how we can do things better. So in terms of solutions, there are many unknowns and knowledge gaps on the potential and limits of nature-based climate solutions in our region. For example, there may be scope to integrate nature-based and human-engineered solutions to help adapt us to climate change. And I'll talk a little bit more about that later in something we call biomimicry. In terms of barriers, what are some of the economic and societal social barriers to the uptake of nature-based climate solutions in our area? And how can we overcome those barriers? And in terms of prioritization, how do we actually, in terms of prioritization, we may only have a few decades left to draw down our emissions. So draw down is basically, how do we vacuum out that carbon out of the air, protect our forests, and rehab our lands? What do we prioritize? How do we prioritize? Where do we prioritize it? So where do we get the most bang for our buck? So technology is a big theme, cross-cutting theme across our programs. And there's a scope to use technology to increase the cost effectiveness of mapping, monitoring, as well as increase efficiency and productivity. And in addition, we prioritize education and outreach activities, such as this event, to discuss the importance of NCS to different types of audiences. Other educational endeavors that we've done has been to film a children's show about tropical deforestation here in Singapore. It'll air later on this year, as well as working with the Singapore Ministry of Education to create a teaching module for continuing education. So to tackle those research questions, we use a wide range of research techniques. So the research techniques are basically different ways that we learn the science. So we collect empirical data through lab work, field work, and remote sensing. And those data sets are absolutely critical for our analytical work to map and monitor and inform the optimization and prioritization of solutions. But it's obvious, this is a really big job. There's no way that we can actually do this alone as one center. So we've been proactively engaging with various stakeholders in Singapore and internationally. And we're open to any other types of collaborations in the area, as long as we can do some greater good for future generations. These partners come from different sectors, including academia, NGOs, NGOs are non-governmental organizations, government agencies, and corporations. So even though we're fairly new, we've hit the ground running. And by fairly new, we just had our 1-year-old birthday in April. So we are really, really new. And so we've really just hit the ground running from remote areas and collaborating even during the pandemic. So I'm pretty proud of that. We've been working on a number of research projects across 3 broad categories of NCS: restoration, conservation, and management. And we look at it across all sorts of different ecosystems. So this is one paper that we've just had. So the top part is basically a peer-reviewed academic paper. And a lot of times in academia, it doesn't necessarily leave academia. So we work with the Straits Times and local publications and media outlets quite often so that we can translate that science to a more general audience. So what is the potential for reforestation in Southeast Asia? So these maps might look a little bit muddled sometimes, and we can totally talk about them. But the overall thing is that Southeast Asia has a huge potential for reforestation. So this is one of our projects that just came out. This is the potential for reforestation. We find that in our region, there are 121 million hectares of degraded means a little bit run down and they can be improved, terrestrial forests, peat swamps, and mangroves that are biophysically, that means so life and physically, so that actual area is suitable for reforestation. The reforestation of these degraded lands could remove 3.4 billion tons of CO2 per year. However, these so-called degraded lands, might in fact be used by local communities in smallhold farmlands or home gardens. So we have to be really careful about not just taking over and restoring everything, but appropriating these lands for reforestation so that it doesn't compromise livelihoods, food security, and the land rights of indigenous populations and local communities. So furthermore, reforestation may require constant site maintenance, protection against threats, including tree diebacks, logging, and forest fires. And we find that as we start to apply these different layers of constraints, the picture starts to change as well. The amount of land that is practically available for reforestation can quickly shrink when we take into all these other constraints. So it quickly shrinks to about from 120 million hectares to 8 million hectares, which is still quite a bit. And in the most constrained scenario, the constrained means the most conservative or the tightest scenario. It's 0.25 billion tons of CO2 that can be drawn down, which is just a fraction of the unconstrained potential. So therefore, it's really important for us to develop better ways of quantifying and mapping and monitoring both the potential and constraints of nature-based climate solutions to inform our decisions and prioritize our investments to get the most bang for our buck. So what's next in our research pipeline? So I'll run through a couple of our priority questions. And nature-based solutions are important not just for climate change mitigation, but they're hugely important for many other ecosystem services and benefits that they provide to society. And this includes biodiversity conservation, ensuring clean air and water, protecting our topsoil and safeguarding our food security, protection against extreme weather events, so climate change, and sustaining livelihoods. So our team is currently working on quantifying and mapping co-benefits of nature-based climate solutions in our region. But among the many co-benefits of nature-based solutions, biodiversity is interesting because it's both a co-benefit, but also a building block of healthy ecosystems. So when we invest in protecting a forest, we protect its biodiversity. Conversely, a high diversity of animals, plants, and microbes in the forest ensures that the forest continues to perform its ecosystem functions that not only sustain itself, but also deliver vital ecosystem services to us humans, including the services of carbon sequestration and storage. So the value of biodiversity is currently not reflected or internalized in carbon pricing. So carbon pricing is basically a new type of market where kind of like a stock, it's bought and sold on a particular platform so that companies and countries that are more polluting can actually invest and conserve, protect, and manage in other countries. So at the moment, 1 ton of carbon from a monoculture, say palm oil, can be priced the same as 1 ton of carbon from a pristine rainforest. Now, intuitively, we know that carbon from the pristine rainforest is so much more valuable than carbon from the monoculture. So our team is exploring ways to quantify the price premium of what we call beautiful carbon. So far, we have focused on green carbon. That's forests. These are terrestrial forests. Terrestrial means land. And blue carbon. And blue because of oceans. And those are mostly mangroves and seagrass meadows. Whoops, I got ahead of myself. But there are several other kinds of high carbon ecosystems in the carbon rainbow that we have received less attention. And that includes teal carbon, which are freshwater swamps and peat forests, as well as gold carbon. And this is macroalgae and seaweed. And what we're finding that's definitely an understudied and misunderstood area of climate, natural climate solutions, is that these macroalgae store a ton of carbon. So they're quite a highly underrated type of ecosystem. More importantly, this is really important. We really need to understand the interconnectedness and interdependence of how these ecosystems actually function together to fully understand the climate change mitigation potential and co-benefits of these other high carbon ecosystems provide. So there are risks. Nature-based solutions are really promising, but they're certainly not without risks. There are 3 big ones in particular. In terms of forest protection, it can be challenging to benchmark additionality, to understand what would have happened if not for this intervention. For example, if the threat of deforestation was inflated, then this investment would not deliver the full extent to its outcome. Alternatively, if the threat is real, say the forest is sitting on very productive lands for agriculture, then the pressure to develop will always be there. And how do we ensure the permanence? How do we ensure that it actually stays in a form of carbon sequestration after the project has ended and after the carbon credits that we talked about on the market are retired? So is there incentive to actually keep those carbon credits? Well, that's one of the questions that we're asking. And finally, there's a risk of development being diverted from elsewhere. So in our globalized and telecoupled society, telecoupled means we might be living thousands and thousands and thousands of miles apart, but as COVID has taught us, we're actually a lot closer than we think. And in our globalized world, it can be challenging to mitigate this risk. Therefore, it's important to develop better ways of accounting for these risks and inform decisions for policy and prioritized solutions. So, COVID has taught us a very important lesson. Why are nature-based solutions so important and all the rage? Well, I think we've seen just how globally connected we all are as humans, but equally as important, COVID has shown us just how intricately connected we are with nature, but also how susceptible we are to the destruction of nature. If we humans are not to just survive, but also thrive through climate change and competing land uses, then we need to really appreciate. So we go to the green transition, and there's a lot of talk about the green transition. So what is it? So we live in an absolutely unprecedented time globally, and within our systems, we can think about how we can make our systems more sustainable for future generations. This includes, and probably the most vital job out there, and how and what we teach our next generations. And this couldn't be more true living where we are now with climate change and the global pandemic as a result. We can not only teach kids the value of importance of nature, but also to learn from nature. This is a relatively new field called biomimicry, learning from nature's forms, processes, and systems to solve human problems. Now you might think, why is there a bird next to a train? Well, that's the Shinkansen bullet train in Japan. And the lead engineer was having a really hard time actually figuring out how to get the sound reduced, but also how to be more fuel efficient. He also happened to be an avid birder. And one day when he was watching birds, he saw the kingfisher dive into the water for its prey with hardly any splash. And he thought, well, if the bird can use that beak to go through one medium and into water, can't the trains do the same thing? And so the Shinkansen bullet train is actually a really great success story about 10%, uses 10% less fuel and also 15% less sound. So there's all sorts of really, really awesome things that we can learn from nature. So that is my concluding discussion. There's a brief overview of nature-based climate solutions, what we do, what they are, and I'm more than happy to just open the floor up for discussion and see how it can tie into different types of disciplines or subjects.